Good morning students. Today we are going to discuss chapter 10, that is wave optics. Now before starting the wave optics, few terms we must have to know. Number one is your wavefront. Now actually what happened, if you place a source emits rays, and these rays disturbs the suspended particles in air. Now when these rays strikes on the suspended particles, the particles vibrate to and fro. Now if you join the particles at a particular instant which are vibrating in same phase, then that particle that set of particles which we have joined can be defined as your wavefront. So let me go through the statement what we have written here. Wavefront is defined as the locus of all the particles of a medium which are vibrating in same phase at a given instant. So just now I have said that if there is a source, the source emits energy or some kind of disturbance. Now that energy or disturbance strikes the particles suspended in the medium. Now if at a particular instant we join the particles which are vibrating in a phase or which are vibrating in same phase, then that line which we have joined by considering the particles which are vibrating in same phase can be defined as your wavefront. Now as specified is here a locus of all the particles. Basically what happened, if you join the particles which are vibrating in same phase, then you will get an wavefront. Okay, fine. But the particles which resides in the wavefront, they are not at rest, rather they also vibrate. So when they will vibrate, they will disturb the adjacent particles. So again, if you join the particles which are vibrating in same phase, then you will get another wavefront which we define as your secondary wavefront. So in this way the wavefront moves. That's why we have written locus, because locus is nothing but the moving points. I think we have done in coordinate geometry locus. If someone asks you to define locus, what you used to do, you used to define an equation, is not it? So that is why the locus is nothing but the moving point. Now classification. Now based on the nature of the source, wavefront can be classified. If we consider a point source, as point source has a spherical symmetry, that's why we will get a spherical wavefront. And these arrows are nothing but the rays which comes out from the source, and it disturbs the particle at a particular instant, and the particles joining the same phase vibration at that instant can be defined as the wavefront. So in point source we will get a spherical wavefront. Now if we consider a line source basically made up of infinite number of points. So here we are considering the end points. So if you consider end points, you will get a circle. Now if you keep on going throughout the length of the line source, you will get a cylindrical wavefront. So if the source is line source, then you will get a cylindrical wavefront, because cylinder has a symmetry with the line. Now next one is your plane wavefront. Plane wavefront we used to get when the source is at infinity, and here the rays are perpendicular to the plane surface. So plane wavefront we used to get when the source is at infinity. Cylindrical wavefront is possible when the source is a line source, and spherical wavefront is possible when the source is a point source. And wavefront is nothing but the line, or you can say wavefront is nothing but the locus of all the particles which are vibrating in same phase. And practically how can you get wavefront? If you consider a source emits energy or the disturbance, it disturbs the neighboring particle. So you have to count the particles which are vibrating in same phase and join the particles. If you join the particles which are vibrating in same phase, then you will get a wavefront. And the particles which you have joined, they are not at rest, they are also vibrating, so it disturbs the neighboring particle. So you will get another set of particles which are vibrating in same phase, and that is your another wavefront. So in this way the wavefront progress from primary to secondary, and then again primary, then secondary, like this. The disturbance which originate from the wavefront, that wavefront can be defined as your primary, and the wavefront that comes out as a result of the disturbance can be defined as your secondary, like this. Now based on this topic, Huygens scientist gives some principle related with the wavefront. So here let me read out. each point on the given wavefront or primary wavefront, which we consider a wavefront a particular, that is your primary, acts as a source of secondary wavelets. So you can say the particles which are vibrating in same phase can be defined as your wavelets. So these wavelets sense the disturbance, is not it. So that's why we have written each point on the given wavefront or primary wavelets acts as a source of secondary wavelets, sending out disturbance in all the direction in a similar manner as the original source of light does. So each point of the primary wavefront is a source of disturbance, and that gives rise to secondary wavefront. The new position of the wavefront or secondary wavefront at any later time is the envelope of all the secondary wavelets at that instant. Definitely these wavelets must be in same phase of vibration. Just now we are trying to show you here. You see, S is your point source and it sends the ray. The rays are nothing but the disturbance. It disturbs the particles, and we have counted the particles which are vibrating in same phase. So dark dot basically gives the particles which are vibrating in same phase. So we have joined these particles, and then as a result we used to get a wavefront, that is P dash, and this P dash wavefront let me consider t equal to 0. Now definitely this dark dot which acts as a source of disturbance can be defined as your wavelet. It disturbs the neighboring particle. So if you want to draw the secondary wavefront, what we used to do, we used to draw an arc considering that dark dot as your center and radius as your CT, because you are trying to define the secondary wavefront at time t equal to t, because c is the speed of light. So if you draw arc considering dark dot as your center and radius as your CT, you will get arc. And what we have to do to get the secondary wavefront, we have to draw a tangent to the arc. To all the arc you have to draw a tangent, and that tangent is nothing but is your secondary wavefront. Okay, and the particles of the secondary wavefront which are vibrating in same phase can be defined as your wavelets. So here we have written what I have said just now. For secondary wavefront at t equal to t, we have to construct an arc considering CT as radius and particle or wavelet at the primary wavefront as center. And the tangent to all the arcs gives a secondary wavefront. I think you have understood. It's a very simple. Once you understand, it's very clear. It's very interesting once it is clear. So next topic which you are going to define is your law of reflection. So this is your plane surface, and AB is your incident wavefront. And we know wavefront and the rays are perpendicular, as we are trying to show it here. So here two rays at A and B, because practically innumerable number of rays are there, but we are considering the extreme rays, and AB is your incident wavefront. So wavefront makes an angle I with the reflecting surface, and where the rays strikes on the reflecting surface, we have drawn a normal, and that angle made by the normal with the incident ray gives the angle of incidence. Now what happened basically, so B point reaches at A dash. At the same time A moves from A to B dash. Have you understood what I am trying to say? The incident ray strikes on the surface at A, so after that striking it will reflect. No, now experimentally it is found that as much time A takes from the reflecting surface to B dash, same time it takes from B to A dash. And to construct the secondary wavefront A dash B dash, what we used to do, considering A as your center and the distance CT basically, or distance same as that of A dash B, we used to construct a arc, and the tangent to the arc considering another point A dash gives you the secondary wavefront. Now if you consider sin I, because rays are perpendicular to the wavefront, so sin I comes here perpendicular by hypotenuse, B A dash by A dash, and sin R if you consider again B dash A by A dash. So here we have written time takes to move from A to b dash is same as time taken from b to a dash, and let it be t. Considering a center and radius as ct. Ct is the speed of light, and arc is drawn which cuts at b dash. B dash a dash is joined, which gives the reflected wavefront. Now since b a dash and b dash a is same, that is ct, that's why sin I equal to sin r. So sin I equal to sin r from 1 and 2, it means I equal to r, and which is the law of reflection. So please try to check these all. It's a very important part, but here you have to understand, because maximum things are in statement form. It's not in mathematics form as we have got before. So that's why you have to go through very thoroughly. So this is all about. Please go through this part and try to check it out. Thank you.